This is Computer Science 455, Software Engineering. We're meeting this Wednesday, the 22nd of April. I hope everybody is feeling okay and ready for the next set of lessons. Okay, would like to talk about software quality assurance plan. Um, the different development teams are now ready to write their software requirement specification based on the client's functional requirements. But don't forget, the non-functional requirements are also needed, and this may not be specified by the client, but you um, uh, could determine that these non-functional requirements like usability, maintainability, portability, and so on and so forth would be necessary to deliver the function um, with the good efficiency to the user. Okay, so I want the QA teams for the Monday group led by Angel and the QA engineers Kevin and Cremena. And for the Wednesday group, QA Wednesday team led by Zitong and QA engineers Enrique and Timothy. This will be your task for this week while the development teams are writing the software requirements specification. Okay? All right. So let's look at um, the website for SQAP. In the SQAP, I have a template for writing SQAP um, um, document. We are again following the format as suggested by IEEE. So remember, every step of the software or every phase of the software life cycle, we define a software process for each phase of the software life cycle. And this SQAP is actually part of testing, which is at a later um, phase of the software life cycle. But we need to prepare what we are going to do for testing while the SRS is still being written. And this is a wrong notion by um, people who, who doesn't understand software lifecycle, that they will wait until the code is done, then they'll do testing. Um, I think uh, the best part of the software lifecycle to determine test cases is at the software requirement specification, because this is the time when the function is being determined, and based on that, you actually determine the test cases. So uh, this time is very uh, critical or important in determining test cases, while the software development team is developing the um, um, the functions that the software is going to have. All right. So let's look at the IEEE 730 standard for writing SQAP document. First, there should be a purpose. What is the purpose of this document? And the reference documents, what are the documents you are using to actually write this SQAP. Uh, what's the organization or structure of the team or the group of people doing the testing? And the documentation is uh, the necessary documentation that you will uh, need to come up with uh, this SQAP. Of course, the documentation would be the SRSs of all the teams that the QA team is going to test. Those will be input to this document, all the SRSs of the Monday or the Wednesday group under this QA team. What are the standards and practices and conventions and metrics that the team, QA team, is going to adapt? And this should be made known to all the development teams. What are the standards and practices that they should follow? There will be reviews and audits. The QA team, from time to time, will inspect the development team whether they are following the accepted standards and practices and conventions that they have stated in the SQAP. So from time to time, they will be poking over your shoulder and try to see if you are following their standards. So they are the MPs, the military police, uh, uh, looking at each soldier or troops if they are following the rules and for safety and for combat readiness of the soldiers. Okay, so reviews and audits from time to time they will poke into your development and see if you are following standard. Now, this is the meat of the entire document, SQAP. These are the test cases that they will try on each of your prototype. So the test cases are determined right now, and they can determine these test cases because you are specifying use case. And the use case are the functional requirements of the software, and this is defined in your SRS. Remember, your SRS contain the use case diagram, all right? And then for each use case, you have defined user interfaces. So from these user interfaces, they will develop test cases for those UI. And the purpose actually of the QA team is to crash your program. All right. So they're not here to pay you a friendly visit, but they are there to crash your program. That's their goal. All right. So if they crash your program, they succeed. Unfortunately, it is a failure of the team and therefore have to go back and fix their software to satisfy the QA team. All right. So that's how we're going to define the software process for testing. Remember, for every phase of the software lifecycle, whether it is software requirement specification, planning, design, coding, testing, there is a corresponding software process that defines what you're going to do or what are the steps principles of software engineering should be applied in the application of the software process. All right. Now, if they find an error, how are they going to report the problem? And what's the protocol for corrective action? How would they um, go through the process of having the team correct the error or the fault. Remember, the purpose is to find the error. The purpose is not to fix the error. The purpose is to find the error, make sure they can replicate the occurrence of the error, and they will give that information to the development team. Development team replicate the events that produce that error and then fix it. And the uh, QA tests again the software. All right. So there are tools, techniques, and methodologies they will be adapting. So um, that would be specified here in this document. There will be code control. So remember, we have Bitbucket and Git bucket that we are using for the repository. So repository is a very important tool that we control the code, especially when you are doing branching or developing new versions. All right. Media control, if you are specifying any media to store the uh, uh, all the software artifacts. Software artifacts refer to all the documentation that you have written for the software, including source code, including design, and any other documents or output like design, UML, uh, class or object diagrams are part of the software artifacts. Okay, supply control. If you have specific supplier that is supplying you with resources, especially if it is outsourced, this is the supplier control section where you would um, uh, you, you would find all those information, records collection, maintenance, and retention. So the records collection, where do we keep that? So we'd like to keep a history of the test cases that you have used, because if you say we update the software because of some changes in a platform or requirements or hardware, the software should still be functioning the same as before. Okay, so you make sure that the software is still running. Training, any training that the QA engineers have to go through, and risk management. And risk management is an important component of management, because you want to identify all the risks or things that can go wrong. And if this you identify this risk, then you should have a procedure or a steps to be undertaken if that risk occur. All right. So that should be specified in the risk management. And appendices are any supporting document that you would need um, to include. All right. Probably I would include user interface designs to be included in the appendices. So you may specify the name of the user interface in the test, but the how it looks in the software will be in the appendices. Okay, so that's the format of the SQAP. All right, so you can find that here in our MAD web site, where this uh, format of the SQAP is stored. Okay. Now we have an example SQAP here, and here is that SQAP for the um, uh, for the spring of 2018, spring of 2018. And we have a small class then, not like you are large, but we have a team lead and a team member. So these are the members of the QA team for that particular class. And here is the format of the IEEE SQAP documentation. So we talk about each of these sections and their purpose previously. Okay, so let's look at the content. All right. So the purpose of this document is to actually test the six uh, projects that we have on that particular quarter. And so recognize SOS. Okay, SOS was uh, uh, was uh, is being developed, and it is part of a continuing team. As I have told you, that we have been developing SOS for the last 3 years or even more. And so SOS is one of those. And I want you to give an abstract of that project that you are testing. So you can get this from the SRS, where um, the development team are writing. So grab a specific part of that document and write it here, just describing what is SOS. Circuit Snap, I haven't mentioned to you this before, but Circuit Snap was a project requested by Dr. Tim Usher. I think some of you have taken physics with him. Very, uh, uh, very lively professor of physics and very knowledgeable in physics. And he requested some way to illustrate the circuit analysis. So instead of physical electronic circuits, to put up an electronic circuit like capacitors, inductors, power supply, we would do it in a kind of a video game where the components are added into a, um, a visual um, circuit board, a virtual circuit board. And so there is a way to pick the component, put it into the circuit, and voila, you have the electronic circuit with the proper um, values of each of these components. And then through Elvis, Elvis is a device that analyzes electronic circuit, would give the analysis of that circuit. So it's a fun mobile app, and so the students, instead of going to the lab and actually physically building up an electronic circuit, will build a virtual circuit using this mobile app. Okay, cool. All right, and I mentioned to you about the congenital heart disorder, which was renamed by Loma Linda University Health Hearts at Home. And here is a small blurb of what it is. And I believe on this iteration, we are developing the iOS only, and that will be for the congenital heart disorder. Plug-in is also kind of an interesting application, and it is actually a mobile app for artists to be able to uh, or those who those who are followers of a particular artist will find information about their favorite band. Where are they playing? And they could stream the performance of the band anywhere they are, or kind of use their music in their own personal party. So this was requested by a client who wants to support musical bands for their fans. Okay, the fans would like to follow their band. Envision is a kind of an office game or family game where during a football season they would bet of who's going to win for that particular weekend, and the most correct guesses of who will win and by how much, or whatever is the rule of who is the winner, will be collecting all these bets, let's say in an office or a family gathering, betting for their favorite team. So this Envision was a kind of a fun game where, let us say, NFL or AFL kind of league are put into this mobile app for predicting the winner. And of course, optimal state, I have told you about the optimal state. It's for helping a first responder cope with distress and pressure from their work. So, a short blurb about what is the project that the QA team is supposed um, to do. Okay, and so that would be for the section number one. References, as you can see here, they are a collection of software requirements specification from the different teams. And you will see a familiar name here. Chas Hampton was the project manager for the SOS. So he was involved there. And you might say they are the authors of this SRS, and so on and so forth. And also, you refer to the IEEE standards for software quality assurance standard as given here in the reference. All right. So how is the project, the team, the QA team organized? Very simple. We only have two members then, and one is a team lead and the other is the engineer, the QA engineer. And here they divided the work among the members of the team. So for the team lead, he has circuit snap, congenital heart disorder, plug-in as the as his responsibility for testing, and Francis is responsible for SOS, Envision, and optimal state. So very simple project management, but of course in a big company, there could be multiple duties. All right. So the documentation that was used, of course, that is needed by the QA team to build this SQAP are the software requirement spec and the software project management plan. So the software project management plan, we haven't talked about that, but I intend to talk about SPMP next week. As soon as the SRS has been completed, then or whereabouts, we will have SPMP, the software project management plan, will be the next step. All right. So the SPMP, software project management plan, comes up with the task assignment. What are the milestones of the team for the seventh week. I've given this deadline to you. Seventh week is the delivery of the first iteration of, of your software, and the final week, the 11th week, will be the delivery and demo of the second iteration. Okay? So, what are the standards and practices and metrics that the QA team specify? There are coding standards. So, these links here are researched by the QA team regarding standard way of writing Java. Unity was used because of the mobile game. If we have one team involved with a mobile game, and that's the Breath of the Coyote. So there's a Unity C# standard, the Swift API design guidelines, PHP for those who are dealing with servers, and XML, Google XML documentation. Now, it is the responsibility of the QA team to make sure that the team follows coding standard. And coding standard means there is a specific way to write if statements, case statements, um, for loops, and all other constructs in the language that you are using, a specific way of how to write it. And that is part of the QA responsibility to make sure each development team are writing their code in a standard way. And these are the useful links that you can find on how to write Java, um, and um, and so or Swift, Objective C, and so on and so forth. Um, uh, the Adapting a coding standard makes your code more readable and easy to maintain. As I said, we're trying to mitigate the uh, the, the difficulty of reading your code by another person. And what we are doing here is when we write it in a particular standard, the person after you uh, could have an easier time understanding your code if you write it in a certain format. So it improves readability. That's all it does. Okay. Any development practices? So they listed four of them. Follow the repository. Commit your code often, especially, but only when the code is functional. Add useful, detailed messages to each commit, and follow coding standards. So there are four development practices that the QA team will require you to follow. Okay, and the software metrics, the most common software metrics I require is measuring the number of faults per thousand lines of code. So this is the density of errors or faults found in your code per thousand lines. And the lines of code is our measure of size. And if you keep a record of when you are doing testing of your own code, by the way, testing is not only done by the QA team. The development team are also using or are also testing their own code. And they do it via unit testing. That means after writing a segment of a code or a function, they immediately unit test their code. Make sure before they move on to the next part of their code that this segment or the function or the class is functioning well. That's what you call unit testing. Another thing that development team can do is if they are integrating several components of the code. Let us say software engineer number one produce module number one, and software engineer number two produce module number two, and they are going to integrate these two components together. After they integrate, they test again the integrated module. So this is what you call integration testing. So every integration that you do, you actually perform integration testing. And every segment of code that you produce, or a function, or a class, you unit test your code to make sure that when they are put together, every part of that code is fully tested. And the number of errors when you test it per thousand lines of code is a measure of the quality of your code. Okay, so the higher the value of this number of fault, that means the less the quality is decreased by that number of faults. So you want to maintain this number of faults at a minimum. Okay, so the reviews and audits, each QA team will have to visit you and review of what you are currently doing, find out where you are, and whether you're following coding standard. They have the ability, the responsibility to actually review your code, all right? And the actual testing is this one. So for SOS, prototype number 3, there is this functionality of main menu. And here are the test cases of what it should be able to do. So uh, um, I would say this is not really complete. What I want here in the for each prototype is that for each use case in your SRS, for each use case there could be one or more user interface that the development team are um, are developing, and therefore you must have test cases for each user interface, not test cases for each use case. I want the testing be done on the user interface, not on the use case, because a use case may have more than one user interface design. So you must test all the UIs and for each of the use case. Okay, do you understand? I'll talk. I'll repeat this again next meeting. So I'm sure you will have some questions. All right. So for each prototype, you have use cases, functionality, and for each functionality or use case, you may have several user interface associated with that use case. So you must have test cases designed for every user interface. Make sure that user interface works. All right. Now, you should also include, in addition to functional test case, you must also include non-functional requirements. So let us say you specify performance, and we usually define performance as the system should come back to the user in 2 to 3 seconds. So you test performance if the system is able to come back, or the cursor come back to you for your next command in 2 to 3 seconds. If they don't, then they fail the performance non-functional requirement. If usability is your non-functional requirement, then you should test for usability, the ease of use of the user interfaces, the sequence of the user interface. Is it not confusing? Is it easy to understand? Is it very friendly? It always give you a chance to input the right information, then if it pass those test cases, then they fulfill the usability non-functional requirements. Is that understood? Okay. All right. So you do that for every project in your group. So here is the SOS, circuit snap, congenital heart disorder, plug-in, envision, and optimal state. All right. So how do you report your testing? Well, each team, QA team that I have, has their own format of how to report. Now, here is the format of the report by the QA team of 2018. So I leave it to the QA team to design their own, because this may not be um, well understood by them. They can design their own. But what you see here is the test case description. What is the test case description that for prototype 1 that you have tried? And then here is the information of whether they pass or fail that particular test case. Now, remember, you should have test cases for each user interface for each of the use case. So a use case may have several user interface. So you must have test cases for each user interface. Okay? So um, it probably could be more information that you see here in this format, but this is a place to start for designing your report. So this report will be given to me, and I will evaluate it, of course, to pass. All test cases should be passed. If you have at least, or if you have uh, at least one error, then you fail the whole testing. Okay, it should be perfect. All the test cases should be passed in order to pass this testing. Okay, there are tools, techniques, and methodologies. As you can read here, they adapted Google Drive for managing the software process. The code control is, of course, using Bitbucket and Gitbucket. Media control, just in case there is an unusual event that happened uh, and you lost your source code from your repository, there should be another medium that you are using for storing backup. All right. So it could be a simple USB if you like, and I would recommend that you keep a separate file or a separate medium to store a backup just in case. And here are the records, collection, and maintenance. Um, they should be keeping a record of all test cases. Test cases must be kept so we can reuse it again and and use it later on when the code is modified to make sure everything works. Training. These are the training selected by the QA team for Android, for iOS, for using Unity, and for using Bitbucket. Um, these links are useful and will help the QA team also get familiar with the two platforms we are using for our projects. Okay. Um, the risk management, there's always something wrong that could happen. Remember Murphy's Law? If it's gonna happen, it will. All right. So identify the key to risk management is the identification of the risk, and you already anticipate, or you kind of prepare for that eventuality. If you identify the risk, you already have a plan on how to mitigate it. So, but the important thing is to identify the risk of what can go wrong, and if it goes wrong, what are you supposed to do, rather than thinking what to do when it actually happens. It's better that you plan now, that you already thought of what is the best way to solve or handle the risk, than uh, having it occurred, and you are uh, thinking about what to do. So better to think about it now before that risk happen. So identify the risk that could happen. Say, for instance, one of your team members suddenly got sick, and so what will you do? You have to transfer those tasks to another person. Uh, so the important thing is identify it now, and then have a plan of what to do when it happens. Okay? All right. So I want all the QA team to start writing their SQAP, while the development team are writing the SRS. I want the QA team to keep in touch with the teams under your group and collect the important information about use case diagram. Who are the actors of the use case diagram? What are the use case? And for each use case, what are the user interface that is being designed to handle that particular use case? Then you base your test cases from the user interface. Okay? So if the user interface says there is a button here that you will click, what happens? If you click that button, what happens? Did the software behave properly, or the software didn't behave properly? And for the non-functional requirements, is it easy to navigate through the different user interface to reach the function that you want? So that's a, um, a measure of usability, of whether uh, the user interface has a very good usability property. All right? Okay, so we'll continue with the requirements analysis. Let's talk about requirements analysis. If you remember, we um, we went through the part of requirements elicitation, and the requirements elicitation purpose is to extract the functional requirements and the non-functional requirements. Uh, Once you get those requirements, you have to analyze those requirements, whether they are correct, they are complete, they are consistent, and they are where they are unambiguous. These four are important um, characteristics um, that you should satisfy. Are the requirements correct? Did you interpret the requirements correctly? Are the number of requirements complete? Did you miss anything? Are the requirements consistent? Are they consistent with what the client really need? And are they uh, unambiguous? There is no way to misinterpret or misunderstood the requirements. Did you misunderstood them? So the software engineer, you must validate, correct, and clarify the requirements specification for any errors or ambiguities. How do we do that? There is a tool in the um, UML diagramming that analyze modeling. It describes how the actors and the system interact to manipulate the application's domain. So, what we have to do is to apply the analysis modeling and uh, analyze how the actors and the system interact together to affect the applications. How does the user and the use case interact with each other? And the advantage of doing this is that the requirements analysis lead to the software architecture design. So it will point to the architecture, but the, uh, the requirements part or the requirements and the specification uh, phases of the software lifecycle doesn't need the software design yet, but through your analysis, it will lead you to the software architecture design, which is important in the following phases of the software lifecycle, where you have to design the software architecture. So let me go through some example of the requirements analysis. Okay. So here, if you remember this diagram, the UML diagram, which actually tells you the whole uh, software process of requirements in the software lifecycle. Requirements, as you can see from here, elicitation, requirements elicitation, your purpose is to derive the non-functional requirements. If you remember, the non-functional requirements are the performance, usability, maintainability, portability, security, all of those are non-functional requirements. And they don't perform any function for the user, but they are important in terms of making sure that the system can satisfy the user in terms of providing the the efficiency of the function and um, other characteristics important to the software. The functional requirements are the functional use cases that the software provides to the user. So functional and non-functional requirements. So here we are in the analysis part of the requirements, and the requirements analysis, you are given tools to actually do the analysis using dynamic model and the analysis of object model, which will lead you to the system design and the object design. Both of these refers to the architecture, software architecture of the software that you are designing. Okay? All right. Uh, let's have an example. Remember this use case diagram? Um, I don't know if you, uh, our book gave this diagram in a weird manner without the UML standard notation. But anyway, here is the field officer and here is the dispatcher, who are the users of this emergency system. So the police officer, let's say on the highway, um, uh, witnessed or was called upon for an emergency. Let's say there is a crash that happens on Highway 215. Okay, so the field officer must be able to report the emergency to the police station, or some location where uh, emergencies are being reported. So the functional requirement of the emergency system is that the field officer will be able to report emergency. So you can imagine this as in the patrol car. There is a terminal on his patrol car, and there is a terminal that the field officer can enter information about the report. Now, that report, when the field officer sends it to the station, the dispatcher receives it, and the dispatcher would be able to read the report emergency, and what it will do is the software, through the software, he will be, the dispatcher uh, can now open an incident. So that will be an instance of an emergency on record in the emergency system, and later on allocate resources to the emergency. So in that car crash in Highway 215 going south, you'll be able to, based on the report, allocate a fire truck if there is a fire going on in the crash, ambulances if there are people hurt, they could send that, or ambulances to ferry people who are hurt. So this is the emergency system that is that you are designing, and there are two users of the system: the field officer and the dispatcher. Okay, all right. So you derive this through the requirements elicitation. You're able to identify these three use cases, and now you go through the requirements analysis of whether these use case are correct, complete, consistent, and unambiguous. Here is uh, the sequence diagram of the um, uh, of the emergency system. Now remember, if you um, if you remember in the first part of the week, I introduced you to UML diagram. And this sequence diagram is a nice UML diagram that you are able to kind of analyze through time what are the different objects or components that are involved in reporting the emergency. So remember, you show here the objects. These are the objects of the system. They could be classes, they could be packages, but for now, it's just important that you label these objects. These objects handle the information that is given to it. And here you see the field officer pressing the button of the report emergency. So you can imagine at this point, the field officer reporting the incident will press the emergency button, which is reporting emergency button. So for now, this is just an object that receives the pressing of the button at the initial time. And when the button is pressed right here, the object report emergency button will create a report emergency control. Okay, so you can imagine this object, when it receives the officer's pressing of the button, will initiate another object called report emergency control. All right, and the report emergency control, remember, time is progressing from top to bottom, and at some time later, it will create another object called report emergency form right here. So the the cause of the officer pressing the emergency button will create an object called report emergency control and create a report emergency form. So you can just imagine that when the officer press that button on his screen, it will see a report emergency form. And that is depicted here. It took some time later for the report emergency form to display on the screen. Now, once the form is visible to the field officer, the officer begins to fill its content right here. And at some time later, when it is all filled up, the officer will submit the form right here. All right. Submit the report and inform the report emergency control that the report was submitted right here. Okay. And report emergency control, it detects that the report was submitted, and it will create an emergency report right here. Emergency report. All right. So this is an object that represents the report being completed and created. At some time later, the report emergency control will now submit the report to the dispatcher. All right. And the dispatcher, through the managed control, there must be a managed emergency control, because there could be other officers reporting emergency in the field. So this managed emergency control is necessary to catch all the emergency report being generated by field officers in the field. So it is waiting, and then report is submitted to the dispatcher. So um, it will receive it and process it, and at some time later, the report emergency control, its task is done. The report has been generated and sent. It will now destroy the object report emergency form that was created. You see this X here? That means the report emergency form is terminated. It has done its task. The report has been submitted, so there is no reason for the report emergency form to exist. It will be destroyed by the object report emergency control. And then the next phase of this sequence diagram is what happens on the dispatcher side. Okay, so um, let me stop here, and I will show you what happens on the dispatcher side. Now, notice here that all the objects you are looking here could be classes or components or packages in your software architecture. For now, you're just identifying them as object, that either receive a message and reacts to the message, which is a nice graphics tool of analyzing requirements. And so it gives you a tool to be able to draw on your have a graphics display that you can analyze and modify if you have any modification later on. Okay, I'd like you to download from the internet the tool called DIA, DIA, and this tool is free, and you can draw any UML diagram that you like. The thing is, this tool allows you to uh, store and retrieve graphics UML diagrams that you can use and save later on. So be prepared to uh, learn how to use the graphics tool, the UML graphics tool called DIA. D as in Delta, I, A. Um, the SQAP will be, I'd like the QA team to start building that, writing that document and coordinate with your development teams on the Monday group or the Wednesday group, and keep track of the progress of the different development teams in coming up with their functional and non-functional requirements, including user interfaces for the use case. So remember, again, what you are obtaining from the different development teams is the use case diagram. So for every actor, there are use cases that they are using from the software or system. For every use case, there could be one or more user interfaces for that specific use case. And for each of the user interface, I want the QA team to develop test cases to test that particular user interface. And that will consist the set of test cases that you will try. So this could be a dynamic uh, process because teams could be designing and then editing their design. So the important thing is to keep track of the progress of the different development teams, and uh, and your SQAP will be updated according to what the development team is doing. Okay, so that's it for now, and have a good weekend. As I have said before, be safe and healthy.